Hello everybody, welcome to the Henstitute. This is Mr. Hennon. This is just going to be kind of a short video to kind of explain free body diagrams. So the idea is if I have some object, let's say that I have a road, and on this road I have a car, and the car is just sitting there at rest. We might want to know, since we're getting into Newton's second law and we need to deal with forces, we might want to know what forces are acting on this car. So what we do is we draw what's called a free body diagram. A free body diagram diagrams all of the forces that are acting on that particular object. Now, a lot of times we don't actually use the picture itself. We'll use like just a box. So I might just draw a box to kind of represent the car, maybe put a point at the center of mass to kind of represent the car. It kind of depends on your situation. In this particular case, I'm just going to go ahead and I'm going to draw both of them so you can kind of see. So if this car is sitting here at rest, what are some forces acting on it? You're going to hear this one happen over and over and over again. There is the force of gravity acting on this object. So there's going to be a force that's pulling this car downward. This is what we call the force of gravity. Now, this is the same thing as weight. So as we get into Newton's second law, we'll use the force of gravity, we'll use the word weight, we'll kind of use them back and forth. And using Newton's second law, we know that force is equal to mass times acceleration. If we're talking about the force of gravity, then this would be equal to the mass times the acceleration of gravity. So you'll see mg pop up a lot. So that would be acting on it. So we could draw it either with the car itself or maybe draw it down here below fg. We know the car's not falling. It's staying at rest. It's not actually moving down. So the only way that could happen is there would have to be some force that's balancing that, that's acting on this car. Where is that coming from? It's coming from the ground. So the ground itself here is going to push up on the car. I'm going to draw that actually acting on this center of mass, acting up on the car. Or we could draw it down here. I'm going to draw it up. This force is often referred to as the normal force. So I'm going to write F with a little subscript n. This is what we refer to as the normal force. The word normal actually means perpendicular. So it doesn't mean like a normal versus abnormal force. It's just saying that it's perpendicular to the surface. So in this particular case, that's what we have acting upward. So if I had this car just sitting here at rest, these would be the two forces that are acting on them. If I really wanted to be picky, if this car is sitting here at rest, it means I have balance forces acting on the object. It's not accelerating. And so I should actually draw both of those about the same size. I didn't really spend too much time doing that, but if you want to kind of show that, that's one of the common things to do. I might actually make this a little bit smaller here, just to kind of show. So to kind of get a general idea, let's make this about the same size as my gravity force so that we have both of them. And that would be it. That would be a free body diagram. And from that, we could try to figure out what else is happening to it. So that's one example. Let's try another example. So now that we have this, I'm going to erase everything. Boom, boom, boom. Bye, bye, bye. I'm actually going to bring my car back. So I'm going to have my car again. Get rid of all my stuff here. Go. So let's get a road again. There's my road. Let's draw my car on there. This time I'm going to say that the car is moving to the right. So it's moving with some velocity. So this is movement. With a velocity. Let's call that v. And in this particular case, so it's moving to the right, it's moving at a constant velocity. But then they hit the brakes. And once they hit the brakes, they start to slow down. And we might ask, what are the forces that are acting on this car? So again, we could draw this with a box if we want to, or we could draw it with the car itself. We know one force right away. We just had it a little bit earlier. We would have the force of gravity acting on this object, the weight of it. And we're going to have a normal force. The ground is going to push up on it. It's going to be kind of a common situation that whenever we're on some surface, the force is going to happen. But this thing is slowing down, so it's accelerating in some fashion. So how do I indicate that? Well, if I hit the brakes and the car is moving to the right and the velocity is no longer constant, it's now actually slowing down, what we know is there's got to be some force that's doing that. Well, where is that actually coming from? We know that basically the wheels are going to lock up and then they're going to start skidding against the ground here. And so we would have some kind of friction force acting on it. And that would be in the opposite direction to its motion. So I would write this F with a little subscript F. This is going to be our friction force. Some kind of force is acting to bring this thing to a stop. And now, when I finish out my free body diagram, that's all I have. So even though it did have some velocity forward, there's no force that's pushing it forward unless you hit the gas pedal. So if I switch this up and I hit the gas pedal and I was actually speeding up, instead of being a friction force that would slow it down, we would have some kind of propelling force. So we would draw that and it would be in the same direction as that velocity, so it would be moving it. So we're going to have a variety of different forces, things like normal forces, forces of gravity. If you have a rope or a string or a chain, you're going to have tension acting on objects. You have friction acting on objects. Basically, think about the forces, and we use subscripts to kind of relate all of those together. So I've got a little document that I want you to give a try to and see if you can draw in these free body diagrams to kind of start thinking about how we do this. Because what we'll end up doing is then this friction force would cause an acceleration of this thing. That's our Newton's second law, and we can find that. These two are balanced, so therefore there is no acceleration in that direction. In other words, technically, if I think about it, I'd have FG acting downward, I'd have FN acting upward, so I would subtract them because they're in opposite direction, and that is what would equal my m times some kind of vertical acceleration, but there is no vertical acceleration, so that just equals 0, and so that's why these two equal each other. So that's just a little bit on free body diagrams. I hope that helps, and look forward to helping you out as you try out the worksheet. Take care.